Hello, and welcome to a new Noction screencast that will walk through the steps necessary to configure multiple routing domains in Noction IRP. This feature enables networks to efficiently optimize BGP routing for networks with multiple physical locations in relatively close geographical proximity. To begin with, a routing domain is a generic term used to distinguish logical locations that work with different routing tables. A routing domain's main characteristic is that its routing tables originate from data received from its locally connected transit providers, while the preferred routes are defined via local policies. Please note that IRP supports multiple routing domains only if a NetFlow, SFlow, or any other flow data stream has been provided to the IRP platform. If there is only port mirroring available, then this feature is not applicable. Throughout the configuration, you will encounter the terms local and global improvements. Local improvements refer to the process of rerouting traffic across providers that serve the routing domain that IRP is installed in, while in the case of a global improvement, IRP reroutes traffic across the providers of a different routing domain. To enable support of multiple routing domains within your IRP instance, navigate to the Providers and Peers section from the Global Configuration menu and specify each provider as per each routing domain. To do this, hit the Add a Provider option, and in the General tab, specify the provider's short name. In our case, I will specify ISP1. Then, in the Router section, select the Edge router with which this provider is connected. I will select here Edge1. Next, specify the probing IPv4 address which defines the source IP from which IRP probes will be sent. I will add here 192.168.122.87. Next, in the maximum load per interface section, specify a value in megabits per second if you want IRP to stop sending traffic through this provider when the specified limit is reached. In our case, we shall leave it as the default value, no limit. Here you can specify a description of the provider. In our case, I shall specify provider 1. In the provider's routing domain field, specify the routing domain this provider belongs to. If the provider is available in the domain where IRP instance is deployed, this value is equal to 1. This value is incremented by 1 unit as per each new routing domain. Since this provider is part of the routing domain where IRP is deployed, I shall leave it here as 1. Next, in the Flow Agents with Outgoing Interfaces section, specify the IP address of the router that supplies flow data, and the SNMP interface index separated by a slash. I will add here 192.168.122.2/7. Next, move to the IPv4 tab. Specify the IPv4 diagnostic hop, which is the next hop IP address of the specific provider. I will add here 172.16.32.32. You will notice that the probing IPv4 address is already specified. This value is copied from the General tab. In the provider SNMP IPv4 address, specify the IPv4 address that should be polled for SNMP statistics. I shall add here 192.168.122.53. In the remote provider ASN, add the provider's autonomous system number. This parameter must be set to keep the AS path attribute in the outgoing announcements. I will add here 65521. In the router next hop address section, add the IPv4 address of the next hop leading to the provider. Here I shall specify again 172.16.32.32. Further, in the SNMP tab, the provider SNMP IPv4 address has been inherited from the previous tab. I shall also specify the provider's SNMP community here as public. The platform will search for available SNMP interfaces to connect to. As soon as the list is populated in the provider SNMP interface field, select the proper interface to be polled for SNMP statistics. In our case, this is the ETH1 interface, so I shall select it here. To enable monitoring for this provider, navigate to the BGP Monitors tab and hit Enable for both sections. External monitor over here and internal monitor over here. Next, fill in the ICMP/UDP ping monitored IPv4 address, which defines the list of IPv4 addresses to be monitored by the platform's BGP daemon. Each specified IP address will be periodically probed for accessibility via ICMP and UDP pings. I shall add here 8.8.8.8. In the BGP session monitoring IPv4 address, add the current provider's IPv4 address that must be monitored by the BGP daemon. Usually this value is the same as the provider's next hop, so I shall add here 172.16.32.32. In the BGP internal monitor SNMP community field, add the community name for retrieving monitoring statistics. I shall add in our case public. And in the BGP internal monitor SNMP IPv4 address field, add the IPv4 address for retrieving SNMP monitoring statistics. Here I shall specify 192.168.122.53. Next, just hit the Add button, and the new provider will be added onto the platform. Repeat the same procedure for all the providers from the routing domain where IRP is deployed, keeping the value in the provider's routing domain as 1. This value shall increase with 1 unit as per each routing domain, and will remain the same for all the providers of a specific domain. After configuring all the providers for all the domains, you will need to measure the round-trip time between your routing domains. These values should be measured between the IRP instances of each routing domain, rather than between routers, to avoid inaccurate results. When you have these metrics ready, navigate to the Global section of the configuration menu and hit Advanced Settings. In the RTT between RDs section, specify the latency between the routing domains relying on the performed measurements. The first two values, separated by a colon, are the routing domains between which the measurements were performed. I'll add here 1:2. Then I'll add another colon, specifying the two-way packet transmission delay between the first and second routing domains, which in our case is 30 milliseconds. Hit Submit to save the changes. Further, navigate to the Core section of the configuration menu, hit the Advanced Setting button, and specify the allowed latency worsening for global improvements in milliseconds. I will add here 30 milliseconds. This way, IRP will perform global improvements only if latency would not worsen more than 30 milliseconds. This value should be increased if your routing domains are relatively far away from each other, so the platform could perform local optimizations in each routing domain, operating similarly to the multiple IRP instances, delivering global alternative routes only when local links are underperforming considerably. After you've specified this parameter, hit Submit to save the changes. To avoid announcing local improvements to a different location, IRP needs to distinguish between local and global improvements. For this reason, you have to assign local improvements to a community. To do this, navigate to the BGP and Routers section of the configuration menu, and specify the community mark for local improvements. This specifies the marker to distinguish the local improvements from global improvements. This parameter represents the BGP community that should be used to match and prevent redistribution of local improvements outside a routing domain. I'll add here the default value of 65535:1, and then we'll hit Submit button to save the changes. We'd like to thank you for watching this screencast, hoping that you will find it helpful. Please let us know if you encounter any difficulties during the setup process, and we will be happy to assist you. You can reach our support team by writing an email to support@noction.com.